It's on seawater chemistry. And do you guys know that you're going to have to do a project this semester? It's going to count as your exam grade?
Yes, I didn't know that.
You're going to have to carry out some kind of project. So, it's probably going to be some kind of seawater chemistry project. Where you can measure something about the water. You might want to measure some of the minerals that are in the ocean water. 55% of the minerals in the ocean water are chlorine. 31% are sodium. Have you ever heard of sodium chloride?
Yes.
What is sodium chloride? Salt. But sodium chloride is not the only salt that's in seawater. There's magnesium chloride. There's sulfur. There's calcium chloride. There's all sorts of different minerals that are dissolved in the ocean water. We're going to take some ocean water and we're going to boil off the water and see what's in it. Have you ever done this before?
Yeah, we did. We boiled, we boiled the salt out of water, but she made the salt water.
Well, we're going to get it from the ocean. What do y'all think of that?
Pretty cool.
Let me let y'all guess this. If I have a beaker full of water, let's say a cup. If I have a cup like this full of seawater, how much salt would be left if I boiled off all the water? Did you hear that, Eli?
Say that again.
Good question. If this was full of seawater and I boiled off all the water, how much salt would be left in the cup?
80.
Would it be like
86%?
Would it be like that thick?
No.
Would there be less? Would there be more?
It'd be less. It'd be like there.
Wait, you said sodium
Would it be
chloride,
just?
salt.
Would it even be enough to see?
Mr. Willis,
Would it be? I mean, and that's what we're going to find out. Yes. Question.
didn't you say sodium chloride and salt?
Yes. Sodium chloride.
So wouldn't it be 86%?
That's 86% of the minerals in the water. It's not including the water itself. So 86% of the minerals are sodium chloride. If you get rid of all the water. Y'all ever heard of the Dead Sea? You know why they call it the Dead Sea? It's got so much salt in it that there's hardly any life in it. Living things have trouble at real high salt levels. And so if the water gets salty enough, there's not much that can live in it. Some bacteria, some types of algae. There's some shrimp that can handle real salty water. This body of water is so salty that you can just float in it without trying, without having to swim. Y'all ever heard of that before?
No.
Now, what is the salt level of our ocean? Anyone have any idea? Is it 1%, 5%, 10%, 20%? 7%? Yeah, let's guess. Let's everybody guess, and I'll give 10 points to whoever gets the closest.
Yes, how much?
So we'll go around. What percentage of our ocean is salt?
4%.
What percentage of the ocean is salt? You. 10. What?
7%.
Okay.
3.
2.5.
12.
3.5.
But you didn't take my number, Mr. Willis.
31.
It's 3.5. How did you know?
Whoa.
Did you look it up?
DeLon said it.
No, I did not.
DeLon said the wrong one, too.
No, I didn't.
DeLon said 4.
I said 3.
Yeah, that's
Or did you say 3?
Yeah.
It's 3.5. She got it exactly right. That's pretty good. Those are good guesses. I'll give you 10. Oh, he's in your group?
No, I wanted 3, but he said it.
Oh, so you said 3.5?
She's in our group, you don't know?
Oh, never mind.
Hey, Eli.
You're over there ranking her, she just
What up, man? What up,
I didn't
Mr.
know
Willis's
about you.
marine bio?
Oh, never mind. Give her the
It's
point.
2021.
Now check this out.
It's
This person
2020.
is swimming
Huh?
It's
in a
2020.
cave.
Oh, it's 2020. My bad.
Listen. This person,
Oh,
to the front there.
okay.
This person is swimming in a cave where salt water and fresh water meet. Now, salt water is heavier than fresh water. So the salt water, it sinks down, stays on the bottom, and the fresh water comes up to the top. And there is an area you can see very clearly where the two meet.
The flooded caverns can play tricks on you in other ways.
Call
What
this a
seems
sea
like
note.
air isn't. It's just another kind of water.
Watch it, y'all watching this. Stop looking at your notes. Look at this.
This is a halocline, a meeting of fresh and salt water. Fresh water from the jungle flows over the heavier salt water from the sea. The saltwater layer is extremely low in oxygen, making it a particularly difficult place for animals to live. Yet some have managed it, like the remipede, one of the most ancient of all living crustaceans. The Maya understood the importance.
Oh, man.
Oh, good.
You call that a C note? C-E-N-O-T-E? C note? When the,
He said 2021. Oh my goodness, there's more. This sucks.
just somebody swimming out. Where the water changes from fresh to salt. If you don't disturb the water, the salt water will sit real low, and the fresh water will sit on top of it. Kind of like if you mix oil and water together, there'll be a clear separation between the two. Now, water in the ocean varies in temperature. Look at this graph here. This is called the thermocline. This is real low, real deep water. This is depth in meters on the side, and this is 7,000 meters deep. That's like 4 miles deep. And look how cold it is. What's the temperature of water that deep? Can you tell by looking at this graph? What's the temperature of water at 7,000 meters deep?
Below 40.
It's a little below 4 degrees Celsius. It's cold. 4 degrees Celsius is real cold. It's almost freezing. As you get higher and higher up, shallower and shallower, the temperature goes up. But it's still really cold. Here it's at about 6 Celsius. But then as you get shallow and you go above 1,000 meters, temperature starts going up pretty drastically. And it might get all the way up here. This is at 24 Celsius. Now we're starting to get at temperatures where you can swim in it. It's not too cold. But you can see the way for a long time it stays really cold, and then it really starts picking up temperature quickly. This change in temperature as you get more and more shallow is called the thermocline. Can you say thermocline? All at the same time? Okay, I'm going to say 1, 2, 3, and at 3 you say thermocline. Ready? 1, 2, 3.
Thermocline.
Good. Very good. That's the change in temperature. Thermocline means the change in temperature, how the temperature goes up as you get more and more shallow. We have devices for measuring temperature of the water. You know what it's called? A device for measuring the temperature of the water.
A thermometer.
A thermometer. We have thermometers. You can measure the temperature of the water. You can see if it's different at different depths. You can measure the temperature shallow. You can measure the temperature deep. Do you think they're the same?
No.
You can check that yourself. That could be your project, Eli. You can check to see if the temperature is different at the surface and down deep of a body of water. What's your favorite body of water?
Pool.
Around here.
A pool.
Where?
A pool.
Now you can't do the pool because it's marine biology. It has to be saltwater.
Oh.
What's your favorite body of saltwater around here?
Gould's Inlet.
Yes, you can go to Gould's Inlet. You can get on a
Kayak.
kayak.
You're not a kayak, right?
Go out there.
Right.
Get a deep water sample. I'll show you how to get that in a minute. Take the temperature deep, take the temperature shallow, compare the two.
Awesome.
That could be your project, sir.
It might be.
Or just
Would you do it just once and that's it?
You can use sonar, and it
You
tells
can do
you
it
the
many
temperature.
times. What do you say about sonar?
I said it tells you the temperature.
Does it really?
Yeah, like on fishing boats, it tells you water temperature at different
At
levels.
different levels?
Uh-huh.
That sounds like your project. I think that's going to be your project.
Wait, do we do it together or by ourselves?
By yourself.
Oh, Josh, you can't take one from me.
You got to come up with a project.
Wasn't the example you showed us together though?
I am running.
What example?
Thomas's and Kyler's? That were they?
Yeah, they did it together. We're not doing it together this year. Sorry. This shows the density of water at the surface. A couple of factors go into density: the temperature of the water and the saltiness of the water. So the more salty it is, the denser it is. And the more cold it is, the denser it is. Until it gets freezing, then it gets less dense. So what water on the earth has the highest density, according to this chart?
Down low.
Down near Antarctica. What ocean is that? The Southern Ocean. Southern Ocean has the highest density because it's real salty down there. Why would it be so salty near Antarctica?
Because the salt can keep the water really cold. That's why it freezes, you know?
It's denser, like ice.
You're on your way. So here's what happens. No, ice is actually less dense. But when the water freezes and becomes ice, the salt doesn't go with it. The ice, like a glacier, not a glacier, what's the word I'm looking for? An iceberg is fresh water. So the water freezes into ice, the salt doesn't go with it. The salt stays in the water, and the water becomes saltier. So it's more dense when it's salty. Isn't that interesting? So you got dense water here and here, and where it's warm, it's less dense. This is a DO meter. Any idea what DO stands for? What would O stand for?
Oxygen.
Oxygen. Got it. Oxygen. What do you think D stands for?
Dissolved.
Yes. This is a dissolved oxygen meter. You stick a dissolved oxygen meter in the water, it'll tell you how much oxygen is in the water. We have a couple of dissolved oxygen meters. You can use them and see how much oxygen there is in the water.
What are those? What was that lab? It may not have been with you, where we stuck them in the cup of leaves.
Yeah, those were CO2 probes.
Oh.
That wasn't
Is it
oxygen.
kinda like that?
That was CO2. What's that?
Is that like that?
It's like that. But this doesn't measure CO2. It measures the amount of oxygen that's dissolved in the water. So you can tell how much oxygen there is in the water with a probe like this. Do you think there's a lot of oxygen in the water at Gould's Inlet, Eli? You're talking about Gould's Inlet. Is there a lot of oxygen in that water? Is there not much oxygen in that water? Does it change? Does the amount of oxygen in the water change? Depending on the day and the week and the month and the temperature?
Yes,
The
probably.
tide, maybe? You could use a probe and check that out. Are you guys thinking about what your project might be?
Use a
I
probe.
already got one in my head.
You could use a probe, Eli.
Now, this is what the water looks like if you're down scuba diving or something. This was taken by a diver. And what color does it look like? What color does the water look like?
Blue.
It looks blue, yeah, turquoise blue. Why? Why is the water blue?
Because it absorbs
Red.
red light.
Absorbing red light.
Ah, good answer. Let's take a look here. Look at this graph. Here's how good light penetrates the water. Now, if you're just right on the surface, you can see every color can penetrate the surface of the water to some extent. But if you go down deep, red doesn't make it down deep. Yellow doesn't make it very deep either. If you're 200 meters down, green doesn't make it down that far. Only blue makes it down that deep. So, everything looks blue down there. Now, if you're up here at the surface, it looks kind of blue because the red only penetrates a short way. And if you take the red out, you'll get kind of bluish-green water. Somebody said turquoise. See, blue and green penetrate pretty well. So if you're about 100 meters deep, everything looks blue-green, kind of turquoisey. Mikey, you get any of this stuff?
Yep.
Seems like you're not.
Mr. Willis, can I use the restroom?
You're going to miss all this stuff.
I'll read it.
Hurry up.
Thanks.
You can see in coastal waters, near the land, you get a lot less penetration of blue light. Blue light doesn't go down so far. There are particles in the waters that will block the light, and it might look kind of brown. Have y'all ever noticed our water look kind of brown?
Yeah.
You might have particles that capture the light and make it look kind of brown.
Ours looks more like army green over sometimes.
Yeah, well look how well green penetrates near the coast. This is a device called a Stretchy Disc. A Stretchy Disc is a device for measuring the clarity of the water, how clear it looks. You take the disc, it's attached to a rope, and you lower it into the water until you can't see it anymore. And you measure the depth by the line, by how much line you let out. You measure when it disappears. That's called a Stretchy depth. And it tells you the clarity of the water. Have you ever been to a place that has water that's real clear? You might be able to drop that thing 50 feet down and still be able to see it. The water around here doesn't have that good of clarity. You might drop it 5, 10 feet down and not be able to see it anymore. So you can get a measure of the clarity of the water with using one of these Stretchy discs. I'll show one to you in a minute. We call it the Stretchy depth.
Do you have one?
I do. I got a couple. Did you know that the deeper you go down, the higher the pressure gets? This is this is called a dry suit. A diver can get inside this suit, and it's so strong that they can go down really deep in this thing. But the pressure, once you go deep enough, will crush you. Humans can't survive down beyond a few hundred meters without some sort of protection because they'll get crushed by the pressure. Do you want to see video footage?
Someone getting crushed with pressure.
The pressure of the water is very
It's not
powerful.
practice, but Grammarly can help. This sentence is grammatically correct, but it's wordy and hard to read.
Get bad.
It undermines the writer's message.
One of the deadliest forces in the underwater universe is water pressure. Yet some people go out of their way to challenge it.
My name is Megan Greer. I'm a freediver by trade. My deepest dive was 170 feet.
That's as far down as a 13-story building is tall. And Megan reaches those depths not with a machine or in a submersible, but simply while holding her breath.
At sea level, the pressure on a human body is 14.8 pounds per square inch. And what that is it's 1 square inch from the surface of the Earth projected all the way up to when the atmosphere ceases to exist at about 60,000 feet.
But when Megan leaves the surface, the underwater universe changes everything. Water is 800 times heavier than air. A mere 32 feet of seawater weighs as much as our entire atmosphere.
33 feet is 2 atmospheres. You add another 33 feet, it becomes 3 atmospheres. And on and on and on. Pressure is not an issue as long as you go by the rules. And most of your body is water. Water is not compressible. Your lungs is what you have to be careful about.
Lungs and intestines, blood, ears and sinuses, even teeth, all parts of the body that may contain air.
When you're going down atmosphere after atmosphere after atmosphere, eventually your lungs go from normal size to being the size of a fist because that gas is getting so compressed.
Like squeezing the air out of a sponge. Eventually her lungs shrink to such an extent that they are no longer buoyant.
You're able to just start sinking like a stone to the bottom of the ocean. By the time you hit 110 feet, you're rocketing.
She is in free fall. If she fails to halt her descent at the target depth, she won't stop until she hits the bottom. Her body is in equilibrium with the water pressure. And it's not just the size of her lungs that has changed. It's her blood chemistry too.
Your lungs are exposed to a higher pressure. It's going to push more gas into your bloodstream.
As Megan swims to the surface, the pressure eases. Like the bubbles in this soda, the gas in her bloodstream needs a place to go, so it refills her lungs. But the decreasing pressure is also robbing her blood of oxygen. She is at risk for what freedivers call shallow water blackout.
There's always the chance, that you'll black out. Just because everything from if you're dehydrated to how did you sleep last night to what you've eaten, everything is having an effect on your free dive.
She is all too aware that the deadly pressure of the underwater universe can kill even the best prepared.
Something that I don't think a free diver can ever forget is that you are so small in the ocean. And you can be taken just like that.
Google, what's the deepest free dive ever? How many feet? Is anyone Googling?
214 meters.
600 feet.
702
700
feet.
feet.
Holy crap.
Hey, you can stop filming. Let's go into this room.